context is like a structured way of representing good practice of some kind. And it actually relates to work that was done in architecture by a guy called Alexander and colleagues, where they developed a load of architectural patterns for buildings. And it's been adapted in a number of different areas, including software, but also in an educational context in terms of pedagogical patterns. So that's as much as you need to know. It's a kind of structured way of representing a good practice, abstract from lots of examples. So we're going to give you 5 examples to give you a flavour of the different ones. And I'm going to look at a science one, predict, observe, explain. So the background, this strategy has been used to uncover individual students' predictions in terms of science, their reasoning for making those predictions around a specific event of some kind. And it can be used in a number of ways. Firstly, to find out students' initial ideas about the problem context. It helps to provide teachers with information about the students' thinking. It makes it explicit. It helps to generate discussion. It motivates the students to want them to explore the concept further, and it helps to generate investigation. So that's the background to the POE strategy. Steps. Firstly, set up a demonstration of an event. So a teacher might set up an example where they put a candle in a glass, and of course the candle will go out. The school children, and then the students have to observe what's happening. They then ask those students to predict independently why they think that's happened, and get them to see what they think about it and why. They carry out a demonstration, look at observe it, write down what they observe, and finally they go towards explaining what they're doing in terms of the amendment. Sorry, I don't know what's happened to the slides here. Now, I'm drawing here, in terms of representing this, using a representation from Australia called the AUTC Learning Design Representation, where they represent a pedagogical pattern of some kind in terms of the tasks the students are undertaking, the problems, projects, investigations, the resources, books, notes, papers, etc., and any support they're provided. And this was developed by Ron Oliver and Jen Harrington, and has been used extensively in a number of settings. So this is the predict, observe, explain strategy representing that notation. Just to remind you, the resources are in triangles, blue triangles, supports in red circles, and the tasks in the centre as yellow squares. So you probably can't read this in detail, but in the middle you've got setup. The students are introduced to a POE strategy and they form pairs. They have an interactive multimedia CD-ROM that they look through. They've got support in terms of explanation of the strategy through a face-to-face lecture and a tutorial about the use of the CD-ROM. Pairs discuss and predict the outputs for a supplied scenario using various resources and getting a number of support, particularly here in terms of peer collaboration. They observe the scenario through a video. They work in groups of pairs to explain the differences. They say the explanations on a computer, and then they have a class debrief, and the teacher facilitates this class discussion. Details of this are on this site. It's a very rich site, and there's lots more details behind that, including the designer's intentions, learning outcomes, context, etc. This is the same scenario or pedagogical pattern represented in the Learning Activity Management Sequence System, which was developed by James DL and colleagues. And here, they're introduced to the problem, they have their topic, they do the prediction, they commit in some ways to what they think about it, they discuss the reasons, they observe, and then they explain. So, slightly different format in terms of how the pattern is represented. This is an up-to-date version, again using LAMS, but developed by Diana Laurenard and Co. in the Learning Designer tool that Yishai is going to talk about later. Working groups 3, initial ideas, record the group prediction, vote, reason, discussion, reason for the prediction, observation, discuss, record, explain, and in this case they're using a wiki to record the differences, and then they have a class summary in the wiki. So an up-to-date version using technologies in slightly different ways than the first example I gave you. So the outcomes of this POE strategy, it's informed, those who developed it would argue, by social constructivism. It's about the collaborative use of POE in a computer task designed to facilitate peer discussion and promote conceptual development of understanding and consensus and shared meaning. And it helps to articulate and justify the students' views through the discussion forums and through the wikis. It helps them to reflect on the viability of other students' ideas, helps them to critically reflect, and then construction and negotiation with others in terms of new ideas. And that's it. Got a whole minute to spare.
Okay, so we will try take into account that all these presentations are online, and in the afternoon session, depending on your on the group that you are going to join, then you are going to get deeper to one or more patterns. Okay.
Okay. One other idea is the think, pair, share learning strategy. When we use such a strategy, sometimes students are called to collaborate, solve challenging and open-ended problems, and come up with creative solutions. But most of the times, students don't know how to collaborate with each other or how to use the resources the teacher gave them. So, the teachers try to foster discussion in order for students to start dealing with a problem, promote the feeling that team members are essential, so we need teamwork, give students a chance to formulate answers in a specific way, and promote the acquisition of presentation and communication. Oh, sorry. What is the solution of the learning strategy Think, Pair, Share, or TPS, if you know it? It's a collaborative brainstorming strategy, actually. At the start of the learning process, the teacher presents a problem and demands from all the students, all the participants, to think about this problem alone, to write down some thoughts, something. At the second level, the learners make groups of two and they exchange their ideas. Finally, they present the outcome of the pairing, and the people give them feedback. Okay, these strategies help the learners intensively work on producing creative solutions. I will steal Yanni's flow pattern, except from the design patterns that Gronia mentioned. There are some patterns that needs from the audience to understand how you can use them, in which flow. Yanni's work was in some flow design patterns, which represents also the actions that should be taken within this pattern. So, here you see the first level, the students think about the problem. Here you see the second level, they pair and they exchange their ideas and they write down some small word. And then they share or they vote. Sometimes we give ideas. There's something wrong with the dimensions. Yeah. Okay, it's okay. Sometimes the teacher gives them some ideas like the power model for evaluating actually the outcomes. Okay, the power model is positives, what's good about the idea, the objections, what bad about the idea, what else, what does it remind you more, enhancements, what's good about it made it better, and remedies. Here's a small example we ran in Greece. Is in the modern Greek language studies, okay, in the final grade of the school. The problem was, is the death penalty accepted from you or not? Okay. So the task is to write a small editorial in a local paper. Okay. The goals, the learners must take knowledge from all around the internet or the teacher. Okay. And exchange the viewpoints, and finally came with a small editorial. The learning materials were online newspapers, posts and questions, editorial evaluation rubrics, things like that. These are the phases, the three phases that I mentioned before. The teacher presents the scope, the goal, okay. Learners individually study the learning material. This is the first phase of the TPS, okay. And learners then asked to briefly write or upload to a wiki or in a Google Docs their opinion. In the phase 2, a teacher forms pair groups, okay, presents the questions that will help identify the problems. Sometimes maybe people, students don't understand exactly what they're looking for. So we need to pinpoint them some questions in order to understand exactly what is all about. The learners say, the teacher offers some extra learning material, learners share their initial ideas, and collaboratively write an editorial article. And the phase 3, all of them read the editorials in pair groups, vote against or for the death penalty, and the teacher evaluates the assignments. That's all.
Great. So, as you can see, this is one of the collaborative patterns. Okay, and this is the. Okay, I don't know. Yeah, this works.
Okay, so this pattern is called Guess My X, and the idea is to try to address the duality between process and product, and that's something that I think in a lot of fields you can see a process that generates some outcome, and there's a sort of educational challenge of getting students to appreciate the relationship between the process and the product and developing a solid discourse around those. So the idea is, briefly, use a challenge exchange game of build this puzzles to combine construction and conversation, promoting an understanding of process-object relationship and leading to metacognitive skills such as equivalent, classes, proof, and argumentation. I'll explain that in a minute. So the idea is really, I mean, after all that kind of fancy text, the idea is actually quite simple. You have a game where there's, say, 2 players, or I mean, of course, it could be 20, but there are 2 roles. One role is a proposer. The proposer constructs a process, derives a product of that process, and shares this in some public medium. The responder then sees this object, the product, and tries to reverse engineer and regenerate the process that produced this product. And if he succeeds, he shares his version of the process in the same public medium as a response to the challenge. Now, what would typically happen is that they would not be exactly the same, and so this is where they enter a conversation, and conversation typically starts with, well, is this the right solution given that your process does not exactly match my original? This is an example of one game where we use this in a project called Web Labs. It was a game called Guess My Robot. The robot was a piece of code that would generate a sequence of numbers. So again, students would build the code that generates a sequence of numbers and post. Here's an example of a challenge page. They posted, a student posted this sequence, and then another student posted this response, which was, okay, here's a robot, here's an initial input to the robot. If you give this input to the robot, it will generate that sequence. This is a hypothetical scenario. So, for example, you could use the same pattern in what I call Guess My Calculator. This is basic numeracy. So, as a challenge, you would pose a set of numbers and some operations and a desired result. And the response would then be, here, this is how I use these numbers to generate this result, right? Or, in chemistry, for instance, you can pose, okay, here are the ingredients and the tools, and this is the outcome compound, and the response would be, okay, here's how you would use these ingredients and tools to produce this outcome. Thank you.
Okay, so another pattern that is related in working in pairs in this case, and then we do have another present by Michael.
Thank you. Yeah, this is the learning contracts pattern. In general, a learning contract is much like, so the idea is much like a word contract. You define the outcomes of what the learners will produce, but you leave a lot of freedom to how they are going about designing and elaborating solutions. And you're only doing probably some mid-way inspections or guiding them the way. But in general, the idea is to give them a stake in their own process, in their own outcomes. And it's a very good thing, for example, in applied subjects, where I say pure lecturing and taking an exam is not the most interesting way of going about the subject matter. So there you can introduce some kind of self-responsibility and self-directed learning by giving them the opportunity of defining on a contract sheet what they want to do and what the expected outcome is. And the instructor and the students sign those contracts, and this is kind of the guide through a unit or even a whole semester. Of course, there needs to be a kind of a frame within which they have to move, so they need to stay within some bounds of complexity of what they are going to do. They will also probably need some support by tutors or instructors. It can be done on an individual basis, so contracts with each student, or on a team basis, so they first team up, decide what they want to do, and have a shared stake in the outcomes. And usually such a scenario is also often combined with a self-assessment of the outcomes, and probably also peer assessment. Yeah, here is a figure that kind of goes through the phases very generically. Yeah, there's a proposal and an approval phase in the beginning. They get a working space where they can share their contracts and the stuff that they elaborate during working on the contract. There's probably a work in progress inspections where they need to go back and redo some things, or if it's fine, they publish their contributions and they share it with other students possibly, and do peer assessment and self-assessment. We have applied this quite often in a web engineering course. It's a computer science course, and we had mandatory from the university administration, we had a mandatory 2 hours per week lecture, and in web engineering, lecturing is quite boring actually. So we gave them the option to do the whole lecture thread and take a written exam on very applied things at the end, which will probably make a lot of sense. And the other path, optionally we gave them, was a learning contract thing. So they were able to define specifically what interested them most in the subject, and they were to do some hands-on stuff based on the contract that was signed with the instructors. Yeah, that's it in a nutshell. If you join me for the afternoon session, we can go into more detail here and try to put this into practice. Thanks.
Okay, and the last one deals with another pattern that's related with collaborative learning. It's the pyramid that I mentioned before. And as you can see over here, there has different levels. People work individually or in pairs, and then in the following levels they join in bigger groups, and finally you can reach, if you want, the whole class level. This is a way of dealing with open and complex problems, and the main objective is how people can understand and reach a consensus on this open topic, mainly discuss, in order to learn and reach a consensus. Okay? This is an example of participants. I mean, in this case, initially we have pairs that join in supergroups. I mean, 2 supergroups, and then one whole class that is composed of these 2 supergroups. Okay. Well, if you go back, we go back to the more pedagogical ideas. People may understand that they need each other to achieve the goal, and probably they would understand why reaching a consensus is a social skill, but also a way of learning. And the main idea is that you have multiple iterations on the more or less same topic. Okay. So, one example. This is one example of a course in network programming in this case, where people have to do flow and sequence charts, so that people normally they have to face a difficult problem, and they have to share at least the ideas and reach a consensus on what's the best solution. Okay, so they might have face-to-face and distance phases. First they work in diets, and then they try to work in the super groups, where they take into account the results of the first phase. Okay, and in the last one, the whole class reaches a consensus and does one single presentation and then a discussion. Okay, so you can see here that we have phases, and we have durations, and we have types of interactions, and we have group formations. And the last thing is that the previous slides could be done without ICT, or yes. Okay. This means that learning patterns or scenarios are not necessarily attached to technology. The point is that technology sometimes has some affordances, and then if we want to have take into account these affordances, then we use this technology. And in this case, for example, besides using pen and paper, we could use Doubleboard for group sketching, Google Documents for writing the reports, and Google Presentations in order to do the presentations in the whole class level. Okay. So this is the first set of presentations regarding patterns and one example of one scenario. And you could see that all these patterns and scenarios probably reflect the ideas of learning design, okay, that we can discuss and apply in the afternoon sessions. And ICT is there because there are some tools that are used during the learning activities, but also ICT can be used in order to produce the learning designs. Okay, so in this set of presentations, first, Bronia again will present the first tool that is Compendium LD that allows the generation of these learning designs. And you can see that although we have worked individually, independently in the last 10 years, we do have some shared ideas, and that's why we're here, but also we have many differences in the way that we design, produce, and use the tools. Okay?
Okay, Compendium LD was adapted from an existing mind mapping tool called Compendium that was developed by the Knowledge Media Institute at the Open University, and we adapted it to specifically be able to visualize learning designs. So the focus is, as I was saying this morning, in terms of moving beyond content. I'm not going to go through this in too much detail, but I hope this morning gave you a flavour of the benefits of moving beyond content towards activities, helps articulate the designs, acts as a dialogic mediating artifact, provides a design record, etc. And this picture here shows teacher creating learning activity to achieve learning outcomes. Student does tasks using tools and resources and produces some learning outputs. That's actually represented in Compendium LD. So this is what the screen looks like when you go into the space. It's got a set of, and that's the main workspace, it's got a set of core icons which come with the standard compendium tool here. So things like question, idea, lists, positives, negatives, etc. And you can still use those in Compendium LD. But what we developed was a specialised set of icons specifically for learning design. And I'll go through what those are in a second. So how do we build a design? Here's the core set. We've got an overarching activity which consists of a set of tasks the students are doing. We've got the roles involved, so student, tutor, or learner, whatever it might be. We've got the tasks the students are doing.